day, everybody. Once again, welcome back to Mr. Buckingham's Physics Problem Solutions. We're looking at our kinematics problems and problem number 5. Alright, let's go ahead and read this question. A boy throws a ball from the ground to the top of a school flagpole. If it returns to the ground 4 seconds after it was thrown, what is the height of the flagpole? Alright, so a couple of things that we can pull from this. We're going to read through the question again. A boy throws a ball from the ground, so it's starting from the ground to the top of a school flagpole. If it returns to the ground 4 seconds, so that's important, we need to underline that, after it was thrown, what is the height, there's our question, of the flagpole? We don't really have a whole lot of information that they've given us here. Really, the only solid piece of information that we have is that the time is equal to 4 seconds. What we're going to do next, right, now that we've underlined our information from the question and we wrote it down, is we're going to draw a little picture, and this picture should hopefully help. Here, we've got a flagpole, okay, and we've got the path of what a rock might follow if we were thrown up, right up to the peak of that flagpole, and then it could fall right back down. The thing that we need to remember is, like our problem number 2 that we did a little while ago, that we can break this into 2 times. That is the time from the ground up to the peak, okay, and we'll call that T1, and then from the peak all the way back down to the ground, and we'll call that T2. Remember here that T1 is equal to T2. That is, it takes the same amount of time to get from the ground to the top of the flagpole as it does from the top of the flagpole to the ground. Okay? They're undergoing the same exact acceleration. Alright? The entire time it has the same acceleration, which we could say is g. G is 9.8 meters per second squared. Okay? We want to make sure that we have that written down someplace so that we know that there is some acceleration pointed down that this rock is undergoing. What they're asking us in the question is, how tall is this flagpole? Okay? The way that we're going to do that is we're going to use a real simple equation to find the time that it takes to get from the peak to the top, and then we're going to do one other slight modification. Alright? Now, when we look at this, the obvious choice that we might want to do is we're going to say, oh, well, time is equal to 4 seconds, so why can't we just do x equals, why can't we just say that x equals velocity times time, right? The problem is we don't have a velocity. We have time, great, but we don't have the velocity that it's going. All that we know is that at the very tippy top, okay, v there is 0. That it has 0 velocity right at the top. That's right at the point that it turns around, stops moving up, and starts moving down. Okay? So we can't use this because there's an acceleration the whole time. That is gravity. So let's go ahead and pull out the formula that we can use here. Okay? Now we might be tempted to try to use this. I put this in as a hint, but it doesn't help us as much as you might want it to. Instead, we're going to use, from our formula sheet, delta x is equal to v naught t plus 1/2 at squared. You might be saying, but Mr. Buckingham, we don't know v naught. But we do. We know that at the peak, that's equal to 0. It's not moving. When the rock hits the very tip top of that flagpole, we consider it to have a 0 velocity. Alright, so we can go ahead and plug in here. We get delta x, right, which is the change in height, that's what we're looking for, is equal to 0 times t, that's convenient because 0t is 0, plus 1/2 at squared. And now we have that the change in height, okay, is equal to 1/2 at squared. It might be really nice for us to take this 4 seconds and plug it in, except there's a problem here. And that is that 4 seconds is our total time. Okay? we need to use is just half of our time. That is the time from the ground to the top, or from the top back to the ground. Okay, so we're going to plug in here our half time and acceleration due to gravity. So we plug in gravity here. Okay, plug in gravity. I'm going to plug in my half time, which is 2 seconds squared, and now I can actually solve for the change in height. That is, delta x is equal to, it'll be, right, 1/2 9.8 meters per second squared times our time of 4 seconds, right? That's 2 squared, right? We can rewrite this again as 2 times 9.8 meters per second squared. How did I do that? I did 4 times the 1/2, okay? And then when we actually calculate that out, 2 times 9.8 is equal to 19.6 meters per second. Meters. We are looking for a height here. Now, if you're kind of wondering about how we got that unit, we were left with meters per second squared, and we multiplied that by seconds squared. That's our t squared. Okay, so we've got seconds squared, okay, those cancel each other out, and we're left with meters. So our final answer is that the height of this flagpole is 19.6 meters tall. Hope that helps a lot with any of your struggles. Let me know if you have any questions. Feel free to stop by and ask. As always, enjoy the rest of your time.